Welcome back to P2. Today we're looking at Trigonometric Identities, Unit 6.3. And this is quite nice. This is the start of a lot of trig work in identities, equations, and later on into Year 13 where you look at more identities. Today we're going to look at two key ones which are kind of the building blocks for some of the further ones that you do next year. And what I'm first going to do is just show you a little bit about them, and for that I want to go back essentially to Unit 6.1 when we had this circle of radius 1, and if you remember the point P, X and Y for the coordinates. Now hopefully you've seen that video and you can remember that X was equal to cos theta, y was equal to sine theta, and of course tan theta was the gradient, so it was y divided by x. So if you remember those from a couple of videos ago. And now what we want to talk about is the circle. So back in your GCSE or your IGCSE, you learned that a circle with the origin 0, 0, so the centre is at the origin, had the equation x squared plus y squared equals r squared. Hopefully you can remember that. You might not, but it's not a problem. But what we're going to do then, if this was the equation of the circle then, and we've got these values here, these can help us. So our x and y, x is cos theta, so cos squared theta, plus y is sine theta, so sine squared theta, and the radius of the circle is 1, so 1 squared. So what we do is we write this as sine squared theta plus cos squared theta equals 1. Apologies there, I don't know why I wrote the y in there. Just a silly move there. But this is our first identity. Now, being an identity, rather than equals, we write an identity sign, like equivalent. So we want 3 lines for it. And all it means is just everything on the left is exactly the same as on the right, and it's just written in a different form, so to speak. Now we can also look at this tan. So tan theta is y over x, y is sine theta, and x was cos theta. And that gives us our second identity here. So tan is equivalent to sine over cos. Now these two identities are going to allow us to simplify trigonometrical expressions, complete proofs, and in some cases also solve equations. So I think now what's best is let's jump into a couple of examples. Now here we have our first example. It's a prove that. If you get like a prove that, you'll notice you have this equivalent sign. It's not an equal sign, so it's not an equation where you can take things from one side of the sign to the other side. It's where you have to focus on one side and convert it into the other side. So the way we approach this is that we either pick the left side or the right side. Now, 9 times out of 10, the questions are usually designed so that picking the left side is the easiest route, but there are the odd one where starting with the right side makes more sense. Now remember, identities wise, we have sine squared x plus cos squared x equals 1. And in this case, obviously, they can be x's, they can be thetas. Ours are going to be thetas because of the question. And tan theta is equal to sine theta over cos theta. So start with the left side, and I should then always write down that left side. And I look at the question, I've only got these two identities to choose from, and I can see that there's sine and cos there. There's no squareds. So let's start with using our tan theta. So tan theta is sine theta over cos theta plus, and I'll do it in steps. This is 1 over sine theta divided by cos theta. Now, dividing by a fraction is the same as multiplying by the inverse of that fraction. So this one's going to become cos theta over sine theta. Now, if again I look back in here, it's a single fraction. So that's what we want to do here, single fraction. So that really means that the bottom is going to be over this sine theta and cos theta. So I'm going to put them over this, well, cos theta, sine theta, but in the order we've got. So that's going to be now sine times sine, so sine squared. Because if I look at it, sine squared divided by cos sine, one of the signs will go, leave me sine over cos, which is what I've got here. Plus, and then this one's going to be cos squared theta. Again, when I check it out, cos squared divided by this, one of the coses will cancel, leave me cos over sine, which is what we got there. Now we know that sine squared plus cos squared theta is going to be 1. And our cos theta sine theta, we'll just write as sine theta cos theta like that. Now you can see that we have shown and we've got to the right hand side. So to finish it off, it's just simply equals right hand side. And that is how we prove something. Starting with either the left hand side or the right hand side. Start with that, write it down, convert it until you get the same as the other side, and then that's how you finish. Okay, and that's what you do. You only work on one side. I cannot stress this enough. You start dealing with this like an equation, where you start multiplying and things like that across the equivalent sign as it should be, but some people put an equals. Then what will happen is you'll get 0 marks for this. And these types of questions probably average 4 marks. This particular one is quite a straightforward one. It's only worth 3 marks. Now, very similar one to our prove, and we've got a show that. Okay, it's very similar to our prove, but this time you'll see we've got an equal sign. So this time we are dealing with the whole thing. So 3 sine theta cos theta over 2 sine theta minus 1 equals 5 tan theta. So what I want to do is I want to multiply both sides by sine theta minus 1. So 3 sine theta cos theta equals 5 tan theta times 2 sine theta minus 1. Now this is to get rid of that fraction, and quite clearly I don't have a fraction in my final answer, what I'm trying to get to. Now I'm going to look at expanding my bracket. So we get 5, sorry, this is going to become 10, isn't it? 5 times 2 is 10, sine theta tan theta minus 5 tan theta. Now clearly there's no tans or causes in here, it's all sine. So let's now work on that. So left hand side at the moment is just staying the same. So we've got 10 sine theta, and this is going to be multiplied by sine theta over cos theta, and this one's sine theta over cos theta. So what I want to do now is multiply every term by a cos theta. So this is going to become 3 sine theta cos squared theta. This is 10. Now you can see you've got 2 sines here, so it is sine squared theta, and obviously we multiplied by cos, so that's gone, minus 5 sine theta. Now you can see that we are getting towards where we should be. Okay, we are heading in the right direction. So let's have a think back to our identities. So we obviously had tan theta equals sine theta over cos theta, which we've been using. And we have sine squared theta plus cos squared theta equals 1. Now I can rearrange this second one, can't I? Cos squared theta is equal to 1 minus sine squared theta. That'll help eliminate this cos squared theta, as I don't want it in my final answer. So now I've got 3 sine theta brackets 1 minus sine squared theta, and that's equal to 10 sine squared theta minus 5 sine theta. Expanding these brackets, I get 3 sine theta minus 3 sine cubed theta equals 10 sine squared theta minus 5 sine theta. We obviously want a positive sine cubed, so let's get every term onto the left. That gives me 3 sine cubed theta plus 10 sine squared theta, and then I need to take away the 3 sine theta from my negative 5, so it's going to become negative 8 sine theta, and that is what we wanted, so as required. Then this type of question would have a second part to it, which would then require you to go on and solve this equation, which is something that we'll be looking at in a later video. Okay, so this type of question, this part we've done here is with 4 marks, and then solving this final equation will be worth an additional 4 marks. Now, I would say there's kind of 2 approaches to take to solving this type of question. The first is to essentially start by ignoring the sign. So I'm going to do 2 methods. I'll do one in black, and then I'll do a further one in another colour. So let's look at it. So first method would be to think of a right angle triangle. In fact, let's make this a bit bigger so it's nicer to see. So right angle triangle, put my theta in, and I know that cos theta is adjacent over hypotenuse. So using Pythagoras, so 13 squared minus 5 squared, and then square rooted, I get 12, so this side here is 12. So very quickly, I know that sine theta is going to be opposite over hypotenuse, is going to be 12 over 13. However, what I need to find out is whether it's going to be a positive value or a negative value. And that's where this bit of terminology comes in. It's a reflex angle. So let's just think about how this all works. I'm going to put my cast in there. My 0, 90, 180 and 270. So the fact that this is reflex means that it is somewhere between 180 and 360, isn't it? As that's what a reflex angle is. And if I look between 180 and 360, in the question it told me that my cos theta was negative. So it's not going to be here because cos theta is positive there. So it's got to be in this section here. So being in this section, only tan is positive in this section. So that means my answer to sine is going to be negative. So sine theta is going to be negative 12 over 13. And what I'm going to do is I'm also going to do b while I'm here, as we get the same value, but it's obtuse. So I won't work out the value again. We know it's going to be sine theta is 12 over 13. We just need to check the sine. So here's my cast rule, 0, 90, 180, 270. and then background to 360. Obtuse angles are between 90 and 180, so we've just got the one section to check here. And this section cos is negative in, which is what we'd expect, but sine is positive in this section. So we leave it as a positive 12 over 13. And that's one way of doing it. That's the way I tend to do it. I approach it as if it's positive, quick right angle triangle to get my values, and then a quick check, whichever type it is, of where it should lie within my 0 to 360. Okay, reflex makes it easy, has to be here. Acute would obviously have to be here. Obtuse, you've got two quadrants to check, so depending on the sign of this one would tell you which quadrant it should lie in. Now, alternatively, we can think of this using our identity. So sine squared theta plus cos squared theta is 1. So cos squared is minus 5 over 13 squared. And obviously this is sine squared theta. So sine squared theta is going to be equal to 1 minus 5 over 13 squared. So 1 minus 25 over 169. And that's going to give me 144 over 169. Then when I take the square root, sine theta is plus or minus 12 over 13. So exactly the same as our previous answer. Maybe a little bit quicker, depends on, what you prefer using. But the second part is the same. So when I'm looking now at, my sections, this part is the same. Reflex, again, we know it's between 180 and 360, and we need to check the question. So cos is negative, so it has to be this section, because again this section cos is positive. And knowing this, we know that sine for this first one, so sine theta is minus 12 over 13. And the same as before, I will do it again just to make sure. But it's obtuse, so it has to be in this section where sine is positive. So this one, sine theta is positive 12 over 13. Okay, so you got your A was sine theta is negative 12 over 13, and for B we had sine theta is positive 12 over 13. And it's just using that cast rule to help you work out which quadrant you're in, and once you know which quadrant you're in, you can then get the sign right. Up to that point, you just got two options to be able to work out the size of the angle. Okay, this one's particularly quite quick, especially if you're going from sine to cos or cos to sine. I tend to use the triangle method because then it also makes it nice and easy for tan. But if you have to find sine and you have given cos and you've got to find sine over cos gives you tan anyway. So there's lots of different ways to do it. But yeah, you just need to have a think yourself, which you prefer. So with this one, it looks a lot harder than it is initially. So we've got an arithmetic series, or sequence I should say. So that means that I'm going to be going up in the same amount. So if I think of the second term minus the first term should be exactly the same as the third term minus the second term. Because that would be the difference. You know, the difference between these two terms should be the same as the difference between these two terms.